Well, they call me the father of Visual Basic because I invented the visual part of Visual Basic that you see on screen, the direct manipulation stuff, the dynamically expandable palette of controls that allows you to paint an interface. And I created that way back in the 80s. I sold it to Bill Gates, and he connected it to his language at the time, his always favorite language, his perennial favorite BASIC, and thus was born Visual Basic. So I like to say I did the visual and Microsoft did the BASIC. That was kind of the combination. But when an early reporter of this phenomenon was a guy named Mitchell Waite, a publisher who was at the time based in Marin County, and he was one of the first outsiders to get a good look at Visual Basic, and he saw it and was blown away. He thought it was a great combination, and he saw my name in the About box, and he didn't quite understand that. And finally one day he called me up and he said, "Are you the Cooper that I see?" And I said, "Yes." He goes, "You got to tell me the story." So we had a long, I forget, lunch or dinner or something, and I told him the whole story, and he said, "You're the father of Visual Basic." And Mitch Waite published the very first book on Visual Basic. It was called the Visual Basic How-To, and in it he dedicated it to me, and he called me the father of Visual Basic. He also mentioned another guy named Gates, Bill something, but he's kind of just on the margins of the story. So, well, the tripod prototype was basically the program that I wrote in order to demonstrate that this cool new visual direct manipulation program could be written. And I wrestled for a long time, because the thing about Windows back in the early days was it was an enormous tease. It hit its technical marks, but it was such a piece of crap when you had to use it that everybody it was the kind of software that only a mother could love. And everybody knew that it needed something to make it useful. It's sort of like the Macintosh, it was all the sexy, fun, cool stuff, but as soon as you tried to use it for real software development, it just collapsed under the weight. It wasn't a professional system. Whereas Windows obviously was. It was a tool that you could use to build the big stuff, but it was a pain in the butt, and it had the most incredibly primitive tools as far as the users were concerned. So from the very beginning, it was clear that it needed a shell of some sort. And I spent a long time trying to figure out, well, what would that shell be? It came to me in a sudden burst of insight. Actually, I was talking with a client. That was what did it. And I realized that the proper shell for Windows didn't really exist. And there was no way you could create one shell for Windows that would satisfy everybody. What you needed was a way for people to build their own shells. You needed a shell construction set. And that was kind of the aha moment, the epiphany that allowed me to build Ruby. I called it Tripod in its first incarnation. I think up non-mnemonic code names. I was looking around in my office and I saw a tripod, and I said, "Oh, I'll call it Tripod." And I've named other things. I had one project I called Camel. I really didn't have a camel in my workshop, but somewhere I saw that image, and so that's what I call it. But that's how I name things. I try to come up with something non-mnemonic. At my office, if people code name projects after Star Trek, I fire them on the spot. What happened is what I showed later on to Gates and sold to Microsoft was Tripod, but I had also shown it to a lot of other organizations, a lot of companies, software publishing companies, and under that name. And so we decided at the moment of signing the contract, somebody piped in and said, "Hey, we should change the name." So I looked around and I said, "I'll call it Ruby." I have no idea where that name came from. I completely pulled it out of the air. And actually I wanted to name my firstborn daughter Ruby. My wife said she'd kill me, and we don't have daughters, we have two sons. So we kind of, finessed the whole, I think my wife did that, And so anyway, so I had a piece of software called Ruby. So that's how it came to be called Ruby. Now there's a whole language out there called Ruby, and there are a lot of young, new guys coming into the industry, and they hear about Alan Cooper and Ruby, and they go, "What? He didn't have anything to do with Ruby." So that's just part of the name confusion in the industry. So Tripod was this basic idea of let's create a halfway decent shell for Windows. And I showed that to a lot of people in the industry, and they all said the same thing to me. They said, boy, this is pretty nice. Why don't you show this to Microsoft? I'm thinking, yeah, right. Like Microsoft would care about something like this. But, you know, I was not having a lot of luck selling it to other publishers. Nobody wants to fight with Bill Gates when they could go fight with pretty much anybody else. You know, so finally I took it and showed it to Microsoft. You see, I've known Bill Gates for a long time because I started my first software company in the industry about the same time that he started his first software company in 1970, late 75. And I started doing business applications, and he was doing languages, and Gary Kildall was doing operating systems, and then money came in and screwed everything up. But I had known Bill for a long time. But you know, Bill, we weren't close or anything. But I knew some other people in the organization, and Bill had these guys that we called them Gates clones. I don't know if they're still there, but Bill had a bunch of guys who were just like him, you know, and they would talk just like him, and they had all of his mannerisms. They looked just like him too. It's amazing. And finally, we ended up through some circular route, got an interview with one of these guys. I forget his name, and the Gates clones had the juice inside the organization, and I had been demonstrating tripod and demonstrating it, and I finally showed it to this guy, and I started giving my standard demo. You know how after you've given a demo a few hundred times, you kind of do it in your sleep. And so I started going through. About 5 minutes into it, he stops and he just pushes it back in the chair, and he's, Bill's got to see this. Okay, good. So this is going to be good. So, you know, because I now had a recommendation from a Gates clone, so now I was going to get a good hearing. And so he arranged a meeting with Bill. So I went home, and I don't think I've ever programmed quite as prolifically or as constantly as I did in the next month. Because I go, oh God, well, it's got to have this feature, it's got to have that feature, I've got to add this whole thing. And so I programmed like a crazed weasel for the next month, and then flew up to Washington and had a meeting with Bill and showed it to him. Bill brought a bunch of his trusted lieutenants in, and so we sat around this giant table, and I started demonstrating this program to Bill. And it was one of the most personally rewarding demos I've ever done. This, by the way, was in the early spring of 1988. So that's 21 years ago, long time ago. And at the time, Windows was a windowing system, but to all extents, to all practical purposes, it was really not much more than a green screen operating system at the time in terms of what it could really deliver. I had done some really cool drag and drop stuff, and where you go over to a palette and pick up a control and drag it onto a window and drop it, and the control would instantiate, and then you could rubber band a line from that control to another control, and the two would be connected, and you could wire them together and when you dragged something across the screen, it dragged across in true animation. So it was actually doing full clipping in the background on a 386. I mean, this was pretty sophisticated stuff for back then. I mean, it was hack code. It was not the kind of stuff that you could ship. But Bill looked at it, and he goes, when I showed him this animation for the first time, he goes, "How did you do that?" I loved it. So I looked at it, and I gave him the only answer I could. I said, "It's magic." One of the guys in the room was, he didn't understand one of the things, I forget what was one of the things that I was showing that it could do. And he said, "Well, why would it do that?" And Bill turned around and answered him. And that's when my wife was with me. She's my business partner. And that's when Sue and I exchanged a look. We realized that maybe we'd had something here when Bill was selling my product to one of his guys. So the demo was a lot of fun because Bill is a really, really smart guy, and he really sees through a lot of stuff, and he sees it instantly. You know, you don't have to belabor the point. And I mean, I'm not a Microsoft. I know there's lots of guys at Microsoft who work with them all the time who know that, but I got it in small doses, and it was a joy to work with Bill because he's so smart. I mean, it was certainly rewarding to work with everybody at Microsoft because they're smart all the way down, and everybody really works hard and gets a lot of stuff done. So you have to move quickly to keep up with them, and it was a fun time working with them. But it was a remarkably short period of time. You know, it was really the time I worked with Microsoft was really about a year, and that was about it. In the late 80s, working with Microsoft was a lot of fun. They were a very successful organization. They had a lot of money. As always, they hire lots and lots of very aggressive, intelligent people. And so whoever you run into in the hallways, you know they're going to be an aggressive, intelligent person who's a real go-getter. And so you didn't have to, you know, explain things. You didn't have to dumb things down for anybody, except maybe one guy, but I won't talk about him. But Microsoft has this campus, this isolated stees where they are off in the woods, and it's just us, and it's like a cult, and they all breathe their own exhaust, and they all speak their own language. One of the things that was always fun to us was learning Microsoft lingo, and because they had these wonderful words for everything that were completely unique. I mean, other businesses, every other profession, you know, develops its own language, but Microsoft really, really treasures its isolation, and any isolated culture, you know, morphs its language. It's one of those human things, and so it was always interesting working with them. But the thing is because they're in this splendid isolation, they can talk themselves into things that they wouldn't be able to talk themselves into if they actually had some contact with reality. And like the whole idea that this whole visual programming thing would be wasted as a shell. There's no market out there, and users don't really want or need that. Instead, let's give it to programmers, which is basically the rationalization they came up to pull Ruby away from the users and have it not be a shell construction set, but instead make it the front end for a programming language and give it to programmers. In our early negotiations, we had talked about extending the capabilities of it and giving it language capabilities, but we had always seen it as a tool for users. As a programmer, I'm sympathetic to the needs of programmers, but the fact is that the people who can put up with the crap because they get paid for it are the programmers. But the people who need the help are the users because they don't get paid to put up with this crap, and they need software that behaves nicely. And here it is 21 years later, and it's the same old crap. The buttons are articulated in 3 dimensions in high resolution, but it's the same old crappy buttons doing the same old crappy things they always did, and it's still really hard to use. And just try asking for help sometime, and you'll see. Number 1, when you use the software, you need to get help. And number 2, when you ask for help, you get a tautology as an answer. So when you get the left-handed relativity potensor help, you know, when you say, what is a left-handed relativity potensor, it comes back and it says, it's the relativity potensor for the left hand. And you kind of go, thank you for stating the obvious but useless. When I originally sold this application to Bill Gates in '88, it was going to be the shell for Windows. And it was going to be user-facing, and it had a very, very simple language that I put into it. I'm not a languages guy. I mean, that's a real specialty. Bill, by the way, is a kind of a languages guy, you know. And after I had really concluded the deal and actually then built the shipping version and delivered it to Microsoft, they kind of got into this sort of soul-searching thing. And I think I don't understand. I don't know exactly what went on inside the organization. But clearly, there was a lot of political fighting going on. Maybe fighting is the wrong word. Let's say lobbying. and forces that never confided in me moved Ruby out of the world of a shell construction set for users and into the world of a visual programming front end for programmers. It went from being a user tool to being a programmer's tool. And that metamorphosis, I was not involved in that. I was still on the track of, delivering to them a product that would be a shell construction set. You have to look at it in the context. Okay, we think today of Windows as this enormous thing, this huge marketing success, this huge dominant operating system that's on every computer out there except a few funny little white ones. And at the time, it was simply not true. At the time, there were many competing windowing systems, and there were several competing operating systems. There were no clear winners. It was obvious that the idea of some graphical user interface was going to work. And if you look back in the advertisements of the day, you'll see a lot of guys competing for mind space in that world. In the late 1980s, Microsoft had a giant dominant product. It was MS-DOS. This is green screen operating system. It was the franchise. And they knew that it was going to have to go away. And they knew that they were going to have to replace it with something. So what they did, they had created this giant success, MS-DOS, in partnership with IBM. IBM did the marketing side of it, and Microsoft produced it. But then Microsoft and IBM got together to build the successor operating system. It was called OS2. And it was this enormous production. And it was the anointed heir apparent within Microsoft. It was considered a product of strategic value, and it was given the lion's share of the new development resources that was going on. It was huge at Microsoft. At the time, Office didn't exist. They had some applications, but this was the biggie. And in the meantime, off in one corner, they had this tiny little kind of run to the litter, stunted little retarded kid brother named Windows that was not a strategic application, was not part of the strategic department within the organization, but it was off in the operating system building and not in the big OS2 building. It was considered a kind of a stopgap solution. It was not considered strategic. But at the time, Bill was very, very frustrated with IBM. He didn't like working with them. He didn't like their architectural style. He didn't like the way things were. I was surprised that I had a couple conversations with him. He was very forthcoming in his frustration of working with IBM. And within a year, he cut him loose. But the Windows guys were not calling the shots. They were kind of the little mouse dancing with elephants. And the elephants were IBM and Microsoft and OS2. And OS2 had a front end called Presentation Manager. And the OS2 guys said imperiously to the Windows guys, "Thou shalt follow everything we do." Okay, so the front end for Windows had to, by decree, look and behave exactly like the front end for Microsoft IBM OS2 Presentation Manager, the front end for OS2. That kind of put it into a Procrustean bed, and it had a hard time fitting in there. What I could do with Ruby is, in about 15 minutes from scratch, create a presentation manager simulacrum on screen. It was about 95% keystroke, mousestroke, and pixel consistent, but it was about 5% inconsistent. Okay, well, I think what happened is a lot of the people who had politically hitched their star to the OS2 started sniping at Ruby, and they said it's not pixel for pixel compliant. Now, this is a suspicion I have. I don't know if this is true or not, but I heard some comments, some rumors, and I think that what happened is it began to become a lightning rod for some of the disaffection inside the organization. And what happened was Windows 3.0 came out and broke the 640K barrier. And it did so with a lighter touch than OS 2 did. And so when it finally released a year and a half later, it really stole the thunder from OS 2. And Gates knew it, and Gates ended up cutting IBM loose and saying, take OS 2, go, take it and go. And IBM really fell on its own OS 2 dagger within a year or two. And Microsoft found, to their shock, that they had a success in Windows 3.0.
What year?
That had to be 90. And because Windows was the operating system that delivered dynamic relocation and dynamic linking, and it broke the 640K barrier. It had the memory modes that allowed you to use the 8086, the 286 architecture, and it was a decent visual platform, mouse support, peripheral support. It was everything you needed to write a good application without having to have the baggage of this enormous giant OS 2 thing. And so developers really started to commit to it. Well, I believe that the damage had been done. Is that even though Windows ended up being ascendant and OS 2 ended up just going off into the weeds, the non-compliance really had Ruby in a bad odor at Microsoft. And so they were looking for something to do with it. Well, this is too good to throw away. What are we going to do with it? But it can't be a shell. Okay, that's my take on what happened inside the organization, because they went dark. You know, a couple months before the end of us delivering Golden Master to them, Microsoft just kind of went dark, and I didn't hear from them for months until finally they sent somebody who, it's like when the military sends somebody to inform you that a family member has died in combat. That's what it was like. I could see this coming, and this person came and said, well, Alan, sit down. We want you to know that we've made some changes. And they explained that they had repurposed it. And they did. And I was, they did it without asking me, and which is wise, because I would have said no. I would have said, no, this is not for programmers, this is for users. And in fact, I went back to Microsoft, and I made a trip up there and met with Bill. Bill was nice enough to see me, and I said, would you please sell it back to me so that I can deliver this to users? And I had no leverage whatsoever, and so it was it was something I had to do for my conscience. And Bill said, but it's a reasonable request, but no. And that was the end of that. Much to my surprise, and I suppose pleasure, a year or so later, Visual Basic appeared in the marketplace to great critical acclaim and commercial success. They did a great thing. Microsoft did a great thing with Ruby. There's no doubt about it. It's a very different thing from what I had originally set it out to be. And so, I tell the story. It's like sending your son off to college, and he comes back graduating with honor, summa cum laude, and a sex change operation. And you have to go, well, that's my boy. I mean, my girl. You kind of have to take your pride in their accomplishments. And so I am the father of Visual Basic, regardless of its gender. Well, I thought Visual Basic 1.0 was a great thing because it had enormous power. Keep in mind that I was a programmer. Now, having said that, you have to understand is that I think BASIC is an absolutely terrible language. It's a language that has always been terrible. It is nothing more than Fortran with a dress on it, and it's a language that should be dragged outside and shot. It's not good. So one of the basic fundamental architectural differences between the Macintosh, all Apple computers, well actually now they've gone Intel, but back when they were a Motorola-based processor, and all Intel-based computers, is the way that bytes are fetched and stored from memory into computational registers. And in an Intel processor, they're flipped when they're brought in, and in a Motorola processor, they're not flipped, they're brought in straight. Well, it turns out that when you look at them in a register format, you want them in high order bit to the left, low order bit to the right. But when you store them, you're addressing from the left, which means low order to the left and high order to the right. So it means somebody either flips and stores them. So it means they're either backwards out there in storage or they're backwards in here in the register. Well, of course, you have to have them the right way in the register. So it turns out that all Intel architecture since day one flipped them and stored them backwards out there, and all Motorola architecture didn't flip them, stored them straight out, and so they're backwards, they're normal out there, but there's extra computation inside the machine. That's called little endian and big endian.
Okay.
These are technical terms of art that are in Wikipedia, and this is something if you are getting a master's in computer science at UW, they will teach you little endian and big endian. I love software. Need I say more?
What do you think of C++?
C++ is an unholy marriage, and its offspring should have oak stakes driven through their hearts. Look, there's been a quest for perfection in languages, and we started with assemblers and compilers, and then we had the giant business COBOL, and then we had Fortran, the stripped down mathematical, formula stuff, and then we had all these weird object-oriented languages and strange creatures and Lisp and Algol and all that stuff, until finally a couple of guys at Bell Labs figured out the solution, and they did it with this language called C. And C is like a race car. It's like an Indy 500 car. It's a fabulous car, but if the average person gets in it and touches that accelerator, wham, they're going to crash and kill themselves because it's a hella dangerous machine. Okay, so C is like that. It's like a bear knife here. Go out there and here's some razor blades, go out and play in traffic kind of thing. That's what C is. And you love it. C was a great language. It's the language I wrote Ruby in. And all decent languages since then have been C form. They've been in the form of C. And the problem is that C was purely procedural. It predated what we know today of object orientation. Okay? And when object-oriented programming really started to emerge into the mainstream in the late 80s, early 90s, the language guys tried to make an object-oriented C. But what they wanted to do was, and their intentions are good, but ultimately it's all screwed up and they should never have touched this, is they tried to create a C that was backward compatible to conventional C and was also object-oriented, and that was Bjarne Stroustrup invented C++. A terrible, terrible language, an awful language, and basically it's unlearnable and unknowable, and I know there are people out there who are good at C, but it's just not a tool for the masses. Now, what Java is an object-oriented, a native object-oriented C-form language. And it's a superb language. And what C# is an even better version. And it's a beautiful C-form native object-oriented implementation. It's a great language. And all languages here on out are basically going to look like Java or C#. It's hard to imagine a break from that. There's a meme out there that says the next thing is going to be better, and the problem is it's not necessarily a correct meme. It's just a meme, and the next thing may have characteristics that are advantageous, but the previous thing will also. And so it's not at all clear to me that there's going to be better languages. I mean, sure, you can tweak them. I mean, look at operating systems. I mean, again, about the same time that C was invented, well, a few years before C was invented, Unix was invented. And every single operating system running today is Unix. Linux is Unix. BSD is Unix. Macintosh is Unix. Windows is Unix. Every operating system running today has the same Unix file structure. Its implementations may take all kinds of shortcuts and have all kinds of legacy that they have to adapt to. And you know, Windows certainly doesn't come with the tool set that a more canonical Unix comes with, but it's Unix. And when the most brilliant language minds of a generation set out to create the great new language and the great new operating system, it turns out that Bill Gates created BASIC, which had already been created by Kemeny and Kurtz, okay? And Anders Hellsberg, his first language was Pascal, which had already been created by Nicholas Wirth. And his second language was Delphi, which had already been created by Microsoft, called Visual Basic. And his third language was C#, which had already been created by Sun as Java. And not to take anything away from Anders, he's a brilliant guy and his creations are spectacular, and he's done more for language advancement than most anybody out there. But what he's doing is he's polishing a pre-existing wheel, or as I like to say, we've reinvented sorry, I blew my line there. We reinvented, not invented here. That's it. I don't program. I play around with software on my own time, but and the problem is because I'm an inventor, I like to work by myself. And the problem is that the way languages have been built, I mean Microsoft has essentially recapitulated IBM. You know, in 1989 they cut the umbilical and set IBM loose to go and wander in the bulrushes for forevermore, and Microsoft went on to define the world of software, but they defined it as corporate IT. Okay, so if you have a giant team of henchmen, of drone programmers, then you can work in the Microsoft environment. And if you are trying to work by yourself and to create something that doesn't exist, hasn't existed before, the Microsoft tools are remarkably inflexible and unsupportive of that. And so what you see is that new software, new ideas in software are primitive in their behavior. I mean, you look at Twitter. Twitter is something new. We've never seen it before, okay? And its behavior is awful. It's offensive and rude and stupid. It stacks temporal messages upside down, and the flow, you can't find anything, you get lost, and it's sort of like looking at the world through a tiny keyhole or looking through a telescope backwards. And it's interesting what you see through it. I mean, it's compelling what it delivers. There's millions of people who are, wasting time at 140 characters a whack, and and everybody is going, oh my God, it's a social phenomenon. It really means something, and it does. It really means something. Okay, but it's like having, remember that movie Amadeus? Mozart was Mozart, but he was an asshole. And that's, That's what Twitter's like. It just doesn't behave very nicely. And so that, now if you want something that'll behave nicely, then you have to work inside a bigger, more highly developed environment, like, say, .NET and C#. But you bring along a team. You bring along a bunch of drones, because what you'll discover is, just as you start getting it to put something up on the screen that's looking pretty good, you're finding bugs in Microsoft's code. Because the stuff is, that thing of, you have 10,000 monkeys and typewriters, and eventually you'll get Shakespeare. Well, Microsoft proved that. They've got, eventually you get C#, Oh, sorry. Well, look, the thing is that the individual guy who is trying to develop new stuff is going to discover that it's all Microsoft tools are, Visual Studio included, are unsupportive of going off the reservation. So if you want to use the canonical database and the canonical database access system and the canonical database presentation grid and have the little things that pop up inside, you can put that together in 11 lines of code in Visual Studio, and it's spectacular. Okay? But if what you'd like to do is something that is not like that, instead you'd like to have things a little more fluid and not necessarily in a relational database and not necessarily presented with a grid, then you're doomed. You're doomed. You have to write it from scratch. The analogy that I use is driving across Florida through the Everglades on a 2-lane blacktop, and it's perfectly straight, and it's paved, and it's level. And you can go 80 miles an hour down that 2-lane blacktop. But if you're 15 feet off to one side of that road, you're up to here in alligators and mosquitoes. Okay? That's what software is like, and in particular in the Microsoft world, is that if you stay on the blacktop, you can make time. Okay? But if you want to do something new and inventive, then you have to roll your own, and you don't just step back 2 steps, but you step back 200 steps. You got to go back to first principles, and all of a sudden you find yourself pulling things apart at the byte level. Okay, well, it's crazy to be pulling things apart at the byte level when you've got a giant corporate behemoth in Redmond who is giving you stuff that moves data around by the gigabyte. I mean, where's the in-between? Why aren't there pieces that are more facile to the builder? And so this is why you see innovation is stuff like Twitter. It's crude, and it's rude, and it's brilliant, and it's innovative. And then you see stuff like .NET, which is brilliant and insanely powerful, but it forces you into a narrow box. Software is something that is fundamentally new in human experience. We haven't evolved around software. We've evolved around things made out of atoms, not things made out of bits. And we fundamentally don't understand it. And I believe that the people who understand it the least are software companies. I think that companies that make things and don't see themselves as software companies, but see themselves as software is a necessary evil they need to work with, actually have a better grasp of the dynamics of software, because they don't come at it thinking in terms of what they can do and can't do with software, which is basically all misconception as far as I can see. So if you look at the history of companies who produce software, what you'll see is they all have an archetypal path. And the archetypal path starts with an iconoclast founder who is a dropout, a nonconformist type. I mean, back in the 60s, hippies became the 70s microcomputer revolutionaries. And what they did was they thought up these cool ideas about software, and they built this cool little software. And it turned out to be the kind of thing that people wanted, and they sold it, and they made money, and they all had these huge crises of conscience. So if you look at guys like Mitch Kapor and Gary Kildall, and there's more. I mean, if you start dredging through you'll find that the guys who really built cool software all struggled with the commercial success. There are a few exceptions, but in general. And what happened is they all struggled with this idea of software, the creation of software, real innovation, thinking up something new in software and trying to fit it into a business structure is problematic. And what's happened is the business people, the business people who come from the business community, as opposed to the guys who are the entrepreneurs who are trying to remake themselves. As business people, they come in and say, "Oh yeah, here we know how to run businesses. We'll run business. We'll bring in the adult supervision, and yes, of course, you can ride your scooters around in the halls, and we'll have food for you 24/7," because they understand the productivity implications of food on premises. But what they do is they come in with their business computations, and what happens is all software product innovation ceases. Sometimes it takes a year or two for the brakes to come on, but nothing ever emerges from that company ever again that is truly innovative, that is something new. Everything that comes out of that company from then on is derivative. So what happens is you'll see for example, with Microsoft, I mean, that's where my mind went. What's a good example of Microsoft? Look at Google. Google came out with this search thing, and it's brilliant. And now they have 150 other products, and they're all brilliant and fabulous, but none of them are making any money. And the good ones they bought from other people. Okay, the same thing at Microsoft is they started with the central operating system, which they didn't write. Okay, and a central language, which they did write, but they didn't design. Okay, and they sold those things. And to this day, the mainstay applications, or the mainstay products, have been the operating system and the language. If you look at Office, they were all acquired outside, with the exception of Charles Simonyi, who was the find of the century, who gave them Word and Excel. And but both Word and Excel were originally done at university, outside of that organization, and transplanted within it. And I'd have to say that if there's an exception to what I'm saying, it's Multiplan that became Excel. That really was a Simonyi thing done on the Microsoft dime, and it's fairly unique. But if you look at any other company out there, you'll see that the products that they sell are their original product, derivative, or something that they acquired from somebody else. And a lot of companies go out and acquire things and do it in a really quiet way so you don't see it. I mean, Visual Studio, Ruby, Visual Basic, it's a classic example in that I was an outsider who brought them this idea of this visual programming language. And it came from outside. They were able to take it to market. They were able to transform it into a product. I mean, that's a huge undertaking. I'm not for a minute making light of it. And when I say that companies don't innovate in the world of code, that doesn't mean that they don't exploit in the world of code. And it doesn't mean that they don't do a lot of incredibly valuable and important work. It just means that one thing of coming up with something from nothing, going from 0 to 1, isn't done in a corporate environment. And I think it's because the corporate environment in general is unsupportive of the kind of apparently purposeless behavior that is the warm, nurturing ground within which that kind of innovation comes. Is that in a corporation, in a corporate environment, you can't have wacky people who are apparently not pulling their weight. And in fact, that's what it takes to do that kind of technical innovation in the software world, because it's really magic. And the guys who've done innovative stuff all will kind of talk about those creative epiphanies, those moments of insight that you get while you're showering or something, or you're sitting on a beach somewhere. And it's hard to fit that into the cost containment structure of a classic industrial age company. .NET is a wonderful thing. What it is the Windows SDK done the way it should have been done 20 years ago. This is a product that I created in 1990. It's the QRC. It's Cooper Software's Quick Reference Card, containing all 597 SDK calls, including 130 calls new for version 3.0. The software development kit. The software development kit, the interface for programmers working in the Windows world. And remember, I saw Windows and I said, here, this is the environment to work in for an applications programmer, because it gave you dynamic relocation, and it gave you memory management, and it gave you dynamic linking and loading. It was the tool that you could work in, okay? The APIs, the Windows APIs, were a technical embarrassment. I've not seen a bigger piece of shit in anywhere. Windows SDK from back in the day, the API, okay, the calls that were exposed to the programmer were awful. And they essentially made Windows unusable. And it's one of the reasons why Visual Basic became such a huge success, is because what it did is it hid all 597 SDK calls. Now it is now if you go to Visual Basic, you'll probably find that there's 5,970 annoying, obscure, overly complicated calls, which, anyway, don't get me started on it. But my point is that what .NET is sort of like the 20th anniversary of the SDK done right. The original SDK was done largely by summer interns at Microsoft. Remember, it was not a strategic application. It didn't have the budget, it didn't have the staffing, it didn't have the headcount, it didn't get the really smart guys. The really smart guys were working on OS2. Then you got these guys. These are the guys who were the B students at MIT. We're working on the Windows SDK. And remember, in 1989 or 88, when I was working on Ruby, I was swapping builds with Microsoft. They were sending me source code builds of much of Windows 3.0. And I read their source code, and it was garbage. And the design of their APIs was garbage. It was really bad, and you can see it in here, where they tried to have something like a print. And it was so bad that they came out with a print extended. And it was so bad they came out with an extended print extended. And that didn't work either. So they came out with an extended print extended. And they're all in here because each one was grandfathered in, because they didn't know how to build on top of things, because they didn't know how to build things in an extensible way. So it was a nightmare going through this. Plus, it was completely undocumented until an outsider wrote a book. Petzold wrote a book, and he kind of created a Rosetta Stone that allowed people to really build significant. I mean, I got an award for writing in Windows, and I tell you, I deserved it for putting up with the crap that you had with the API. .NET normalized the API, and it does a fine job. .NET is really a delight to use. It's a delight to understand. It's brilliant in its conception, and it's superb in its implementation. It is a strategic, or was at the time, it's now been knocked off its throne, but at the time it was seen as a strategic initiative, and it had the money behind it, and it had the brain, the Anders and Goo and these guys, I don't know them, but obviously these guys are razor sharp, okay? But don't talk to me about innovation, because what they're doing is they're doing the Windows SDK, and underneath .NET is these 597 calls. They're still there. And you can still see the traces of them. And the really annoying thing about it is this stuff back in the day wasn't reentrant. And so the whole front end, the whole user-facing side of .NET is not reentrant. And so it turns out that just like back in the old days when you had to do your own manual link editing in source code in Windows, you have to wear belt and suspenders and an old piece of rope in order to work with the user-facing side of .NET, because even though they completely rewrote it, they still didn't go back down and dig up the bodies and bury them properly. And it's still in there. Okay, so, one hand giveth and the other taketh away. I mean, thank you, Microsoft. You're this giant, enormous, bazillionaire company. And why don't you spend some of that money on creating decent software?